You're probably wondering what's inside this, I guess, burgundy box. Well, you're probably not, because by now you've seen the title of the video. Well, anyhow, let me open it up and show you what I've got. What we have is a Hickok, down here, Hickok Model 600A tube tester. Well, if you're young like I am, you may not know what this does. What does it do? Well, it tests. Well, let me grab one. Should have had this ready. Vacuum tubes, like one of these. This happens to be an older 1930s style type vacuum tube. To make sure that the filament and the like are still in good shape. This particular one has a heated cathode instead of a filament, but either way, same thing. And it actually dynamically tests to make sure that it amplifies as it should and that it hasn't gotten weak, that coating on the cathode hasn't depleted itself of electrons as it does over time. So if you're in a generation slightly older than myself, I'm a younger guy, I've never personally needed to use one of these. It's always been by choice because I grew up in an age where computers were ubiquitous. So certainly something like this isn't something that I would need to use as part of my daily life. However, people a little bit older than myself, they would have went to their corner drugstore and they would have bought vacuum tubes like you now buy batteries. You would go through if your TV stopped working and you would take out all of the suspect tubes or maybe just all of the tubes for good measure, and you'd put it on the tester that they have there at the pharmacy or the drugstore, and you'd figure out which ones were good and which ones were bad. You'd have a meter much like this, where you have red means bad, green means good. And then you'd go through and you could purchase the replacement tube that you'd need. You'd come home, put it in there, and hopefully that would fix the problem. I suppose there were people that weren't so savvy that perhaps had to hire a TV repair technician to replace the tubes. But my general feeling of it, tell me if I'm wrong, is that generally the average person would go and replace their own tubes in the TV or the radio or whatever they might be using. So anyway, yeah, that's the kind of story that I heard from friends of mine, older gentlemen that I had worked with, that reflected upon their history with vacuum tubes, and something like this almost brings a tear to their eye. There's a bit of nostalgia in that. For me, no nostalgia, but it's really fun. Look at all of these knobs and buttons and dials. It's just fun to operate. So I had a couple tubes that I wanted to test, and I figured I'd just turn on the camera and show you how this thing works. So the first thing you want to do, somewhat obvious, maybe not quite as obvious as you would think, turn it on with the power switch, obviously, and let it warm up, because this device itself, this tube tester, actually has its own vacuum tube inside that it operates on. I don't know of any modern type tube testers that don't use a vacuum tube. Certainly there's tube testers out there that don't need a vacuum tube to operate. But this particular one, because it's a mutual conductance tester down here, instead of the cheaper type, that makes a difference, and that is why it needs the active component of the internal tube. Let me just explain really quick the difference. You have basically a cheaper type of tube tester, one where more or less it just applies a current across the tube itself, and if it conducts, it's good. So all it's really doing is checking what's called emissions. It's checking to make sure that you're getting electrons off of that heated cathode or filament, whichever it may use, and that it's operating. Okay, that's good enough in some applications, but in other applications, and probably just a better way all around to test the tube, is with like a tube tester like this, which is called a mutual conductance tube tester. What that does is it effectively puts the tube in an amplifier circuit, and it verifies that it amplifies by the amount, by the strength that you would expect it to amplify. So it's a little bit more rigorous of a test, and it's going to give you a little more information about how good that tube really is. Because you may take a tube that read good on a cheap tube tester, and then you put it in circuit, it doesn't work. Well, why? It's a perfectly good tube. Yeah, but it's only as good as the tests that you performed to figure out what kind of performance it was giving you. So a tube tester like this, really highly sought after in the tube community. And Hickok is definitely a really good brand. So I can highly recommend this particular unit. Anyhow, the original reason that I zoomed in here on this particular piece of the equipment is this is what they call the roll chart. And what it does is it gives you the tube type by number, and then it gives you all of the information that you need to set all of these dials and knobs and push buttons in order to test the actual tube. For example, you've got the filament voltage here, and then you have some knobs that are up top we'll look at soon, and what to set those to, a bias knob, English knob they call it, and then which button to press to actually test, and then the mutual conductance number that you're looking for to know that you have a good tube. And then over here, there's some notations. You'll notice that cap equals P. There's also a cap equals G. It just depends on that particular tube. And when you're talking about a cap, you're talking about this piece up here. This is what's called a grid cap. And the grid, which is, in transistor terms, essentially the base, is on top of the tube. And the reason for that is because these are radio tubes specifically, and you need to be able to lower the capacitance of that grid in order to operate at the high frequencies that a radio operates. So what you do is you minimize the amount of distance that particular lead needs to travel near other leads. So if you brought it down to a pin here, well, you'd see it'd be parallel for a long time with these other pins. That would increase the capacitance. It'd make it no good for high frequency work. So what they do is they bring the lead up to the top by itself, and that lowers the effective, what's called Miller capacitance of the tube. Okay, so now let's find the specific tube that we want to test. I'm going to go ahead and test the 76 tube first. So let's roll through our roll chart. No, wrong way. Oh, just so happens it's right there, 76. So I happen to know, and well, my chart tells me anyhow, we have a filament voltage of 6.3, so that's this knob here. That's already set to 6.3. And we want JR, which is these two knobs here. That happens to already be set also. Grid goes on 3. Next one is 2, 0, 4, 0. And what's nice about this particular tester is it tells you what these things mean. This redirects the filament voltage that you've selected here to the appropriate pins on the tube. This directs the grid to the appropriate pin on the tube. And that's what this does, because essentially you're testing hundreds, maybe thousands of different tubes, and you need to be able to adjust this to match the pinout and the voltages that you would expect for many different types of tubes. So it needs all of these knobs and buttons and things in order to be able to test a multitude of different tubes. So what you're doing down here is you're just telling the tube tester which pins to send any given signals to. So, for example here, because this isn't a pentode, there is no suppressor grid, and that goes to 0. It's just not used. Sorry, it's very dark in here right now, and there's a reason for that. I plugged in my tube, I'm turning it on, and I want to see if we can see the glow come up in that tube as the cathode actually heats up from the heater. I can see it outside of the camera here, and maybe you can see a couple little dots in there as it starts to heat up. Let me see if I can zoom in a little more. Up, too far. Okay, yeah, you can kind of see it toward the bottom. But yeah, there's your little heater in there that emits the electrons from the cathode. Alright, so our tube is in, the filament's heated up. Very important that you take the time to let this properly heat up to operating temperature, and even go a little bit longer than you normally would. A tube like this takes anywhere from 10 seconds to as much as maybe 30 seconds to heat up and start working. I go even longer. I let it heat up for a few minutes, walk away, let it do its thing, just to ensure that you're not throwing away a perfectly good tube. They don't make these tubes anymore. The only way that you can buy, for example, a 76 tube is NOS. What is an acronym for New Old Stock. They built so many of these things back in the day because it was used in literally everything that there's still warehouses full of vacuum tubes just sitting there. They're brand new, never been used. They don't degrade much over time because there's a vacuum in there, so nothing oxidizes. But there's still a limited supply. It's like the oil down in the earth. The more of these you use, eventually we're going to come to a point where you can't get them anymore. And that's a shame. I think, like I said in the beginning, there's a lot of nostalgia to this. You really want to be able to play with these things. There's a lot of people that have fallen in love with vacuum tubes, myself included, strangely enough, for a guy that's into digital electronics. Because this is our history. This is where we came from. This is what we used before we had transistors. So, anyway, the point of the story is you want to let this heat up enough because you want to make sure you're giving a good test. You don't want to throw away something that might still be good and is not irreplaceable, but there is a limited supply out there. Anyhow, I did let that heat up to the point, to that point, I should say. And now, so we want to look, you can't see it down here, but my bias is 29, which is this knob here. So I'm just going to set it to 29. Good, okay. English, 65. And this English knob, what does this do? I think this might be a Hickok specific thing. What this does is it lets you look at your meter in what they call English, right? Where you can just look at it and use the red and green scale up there. If when you press your button it comes up into the green, you know it's good. If it's in the red, replace. There's a little question mark in the middle, so if it's kind of questionable, then think about replacing it soon, but it's probably good for the time being. Just maybe make a note. If something goes wrong, well, that tube's probably your prime suspect. The other thing that you can do, let me zoom in here on your English dial. You can see, and sorry for the handheld use here, you see these little orange dots maybe? What that does is if you set it to one of those three orange dots, those correspond to the three different scales on your meter. So if you didn't want to read it in English, as they call it, the red or the green, you could actually read it directly in what they call micromhos, is what mutual conductance, transconductance, I should say, is measured in. So we may do that just to see what our actual transconductance is as compared to what we'd see on our chart here under mutual conductance, and just kind of see how this tube compares to the 1450 that we'll expect to see. Alright, so I've set all my knobs and dials. Everything should be good. Our tube is now heated up. The first thing that we want to do, we want to come down, let me get that into the shot here. We come down to this knob here where it says shorts, and the first thing we want to do is test that vacuum tube for mechanical shorts, because vacuum tubes are very delicate. Inside here you have lots of little grids and elements that are very, very fine wire. Everybody knows vacuum tubes are extremely delicate. So it wouldn't be difficult if you were to drop this thing or jar it. I had these shipped to my house, so who knows how the U.S. Postal Service handled these along the way. They can easily become damaged, and it would short out between various components. So, first thing that you want to do is test that. Now, there's tubes that have shorts that occur when it's cold. So a tube may start out shorted, but then as the elements heat up and expand, they no longer short. By the same virtue, you have tubes that only short when they're hot. So there's been instances I've actually come across where a radio worked just fine as you start it up and turn it on. It'll work for maybe 30, 40 seconds, and then a pop and it stops working. Well, what happened was there was a tube that would have an intermittent short. So as soon as something would heat up, that metal would expand, make contact with another element, and, well, yeah, you know what happens next. Shorts out. So what we're going to do, this is a little neon bulb down here. We're going to turn this knob through the various positions one at a time, and we want to look for a solid neon light here. If we do get a solid neon light, that means that there's a short. If this flashes just for a quick second and then goes away, then we're probably okay. So let's just go through here. You see, notice that flash. That's okay. As long as the flash goes away really quick, you're in good shape. If it stays, that's when you have to worry. Couple little flashes there, but nothing to worry about. Go back. And then we leave it in the tube test position up here. I'm sorry, tube test. And our little chart here says to press P4. So let me zoom in on the meter. And I'm going to go ahead and... I'm sorry, I missed a critical step. There is a knob, let me zoom back out here, down here, called line adjust. That's very important because the voltage coming out of the wall does actually vary. And this particular machine, or unit I should say, it's not very, well, I guess it is mechanical with all these knobs on there. This particular unit is based on that 120 volt line voltage, or in this case 115, and inside that knob there's a little variac, and you can adjust the voltage coming to it. And on your knob you can see, not knob, I don't know why I said knob, on your gauge here you can see a little position there called line test. What I'm going to do is press the line test or line adjust button here, which P7, then I'll hold that down and then adjust the line adjust knob until it lines up with that line test. So there we go. See, it's high. Let me bring it back. Okay, let go. One weird thing about this particular unit, and it's the reason the owner actually sold this thing on eBay, is the meter doesn't go back down to zero. It kind of sticks there, and it has to do with the static on this particular plastic display. They were notorious for doing this. Static would build up and the meter, you know, would stick, and that's really the issue. Because I've taken this thing all apart, I've cleaned it, and if you don't have the plastic cover on, everything works fine. The second you put this plastic cover on, well, it doesn't work correctly anymore. One trick that I've seen people do, and I actually tried it, it worked well, I rubbed it with the dryer sheet. Because dryer sheets have that anti-static compound, whatever it may be in it, and it worked. It took a lot of that static out of there, but still, you see, sometimes it sticks. Anyhow, let's do this and make sure it's repeatable. And it's not. So I'll come back up. We're going to do this a few times until it is repeatable. Okay, so it is now repeatable. We go directly to that line test position every time. So, we've got this thing calibrated, ready to go, finally. I know, it's a lot of work, but that was the fun part. Well, anyway, that's what I'm told was the fun part, and I certainly don't mind going through and selecting all the knobs, and there's something really satisfying when you press the button. And I'm going to go ahead and press the button, and now, finally, after all this setup, we're going to get whether or not this tube is good. I hope it's good because I ordered it as a new old stock tube that's supposedly tested and certified as a good reading tube. So here we go. And sure enough, we're in the good. Okay. But there's one more thing that I want to do. I want to adjust this English knob to a point where we can read the actual mutual conductance directly off of the meter. So let me get that adjusted and I'll get back to you. I just want to show you again those three dots. We've got a dot here, here, and here. They're orange. They're very hard to make out on camera, I think. Anyhow, that corresponds, like I said before, with your three scales, which have these ultimate full scale resolutions here, 3,000, 6,000, and 15,000. If we come down to our roll chart, sorry, still getting used to this thing. I have never taken any kind of acting or videography class. I'm just doing the best I can here and kind of learning as I go along. So our mutual conductance is 1,450. So what scale are we going to end up in? Well, we've got 15,000, that's way too big. 6,000, we can go down lower. 3,000, okay, so that's what I set it to. That's our lowest scale, and we should end up somewhere in around here, just under 1,500, just about half scale, with our expected 1,450. So let me give that a shot. Okay, let's push the knob again. What do we get? Look at that. We're at about just over 1,400. Well, it's an analog meter, you know, it's not all that accurate. Let's call it about 1,400 micromodes. So that is a good tube. By any measure, that is a good tube. I'm not going to go through and test the other tube. It's very much the same thing. The only difference being that there's a little clip over here that you would plug into the P position or the G position. I don't know which one it is. And there's a little clip that you would attach to the top. But otherwise, the testing is very much the same and probably rather boring. Unless you want to see that, let me know in the comments and I'll make another video testing a grid cap type tube. Anyway, I hope you found that interesting. I really just wanted this to be a quick look, and I think hopefully I kept this pretty brief, or terse as we say in the programming world. Sorry, I had to put something geeky in there. I hope you found this interesting, and for anybody that might be older, I hope there was a bit of nostalgia in that. So, if you liked what you saw, make sure you click like. If you haven't already done so, subscribe. Posting new videos every week, try to do 2 or 3, and follow me on Twitter at OhmsAtHome. We'll see you. Oh yeah, one more thing I want to point out about tubes in general. When you're pulling them out of anything where they may still be hot, well, essentially. Don't pull these out while they're still hot. A, you could burn your finger on the glass, and B, the elements inside of that tube are warm, hot, I should say, very hot, orange hot, or sometimes red hot, and you don't want to compromise the metals inside that tube. If they're hot, they're flexible. So if you pull it out and you bump the thing, you could easily cause that to flex, distort, and cause a short and other problems. So don't pull it out while it's hot. Also, some tubes in particular are worse than others. Philco brand tubes especially used a water-soluble ink on here. This 78, you see that? These tubes are going to get dirty over time, especially when they're hot. It tends to attract dust. Dust kind of bakes to it and it gets nasty. So you want to clean that off. Well, just make sure you're very careful around this 78 because you could actually wipe the 78 off if you're not careful. And then you're left with the tube and you don't know what it is. So anyhow, just wanted to point that out. See ya.